This training module is an overview of water quality modeling. It is training module 7.01 for the Stochastic Empirical Loading and Dilution Model, SELDM. The presentation has 12 slides and will take about 7 minutes. It was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration. In this module, we will learn that water quality is complex and good data requires characterization in time, space, and with hydrologic variability. We'll also learn that the training materials include information you need for further study. The highway-runoff database indicates the importance of different constituents, and the stochastic empirical loading and dilution model can be used to simulate random, dependent, and transport curve water quality values. To simulate stormwater quality with SELDM, we need representative statistics for the upstream and highway runoff concentrations. The schematic diagram shows a stream with a highway crossing. The upstream load for each runoff event is the product of the upstream concentration and flow. The highway load is the product of the highway concentration and runoff flow. The downstream load is the sum of the components for each event, and the downstream concentration is the load divided by the sum of flows. Both the upstream and highway runoff concentrations can be modeled as stochastic variables by using different methods. The photographs show automatic sampling sites on the Charles River and Interstate 495 in Massachusetts. This module is an introduction. We will cover only the basics as they relate to SELDM modeling selections. As the saying goes, in for a dime, in for a dollar. If I start to describe water quality in detail, we could be here for 2 weeks. For example, the U.S. Geological Survey has more than 20 water quality courses. Each are a week or two long. I cannot hope to make you water quality experts in one day, but this video and the videos on random, dependent, and transport curve methods should give you the information you need. The training materials provided as part of the class have reports covering highway runoff and background water quality. There are many constituents of potential concern depending on your local conditions. The occurrence and ecological effects determine the risk for each constituent. This graph shows a water quality selection system based on the likelihood of adverse effects in receiving waters on the vertical axis and the likelihood of occurrence in the environment on the horizontal axis. For example, trace metals commonly are of concern in highway and urban runoff studies because they have adverse effects on some aquatic life at low concentrations, and impervious surfaces commonly are a primary source of trace metals in receiving waters during storms. This graph shows the occurrence of runoff constituents in version 1.0.1 of the highway runoff database. The sample counts indicate which water quality constituents are considered as the most important. The top 15 constituents in terms of the number of samples are total suspended solids, total copper, total lead, total organic carbon, total cadmium, total phosphorus, total gel-doll nitrogen, total chromium, total hardness, pH, total nickel, dissolved zinc, dissolved copper, total nitrate, and dissolved organic carbon, which all have more than 1,000 samples. The suspended sediment concentration, which has 451 samples, is shown because the U.S. Geological Survey has found total suspended solids to be fundamentally unreliable for water quality analysis. More recently, a number of highway and urban runoff studies have come to the same conclusion. A random variable is modeled using the average, standard deviation, and skew of the data. Random variables commonly are shown as box plots. This graph shows samples of total copper concentrations from Massachusetts highways on the vertical axis and annual average daily traffic as categories on the horizontal axis. The white triangles show the maximum and minimum. The white circles are the average. The horizontal line within the box is the median. The length of the box indicates variability and approximates the standard deviation. The symmetry of the box above and below the median indicates the skew. This graph indicates that traffic volume is not a strong predictor. The site with the highest concentrations also is within a city. A dependent relation is a regression line with random variability. Dependent relations are useful when commonly measured constituents can be used to simulate constituents with fewer data. This graph has suspended sediment on the vertical axis and total suspended solids on the horizontal axis with logarithmic scales. The graph shows a regression relation that can be used to estimate suspended sediment from total suspended solids. The yellow circles are measured concentrations, the yellow line is the regression relation, and the gray dots are the data generated by using the line plus or minus random scatter around the line. A transport curve is a regression relation between flow and concentration with random variability. This is a graph showing total phosphorus concentrations on the vertical axis and upstream flows on the horizontal axis. Data are from Sasko Brook in Connecticut. The blue circles are measured concentrations. The yellow line is a two-segment transport curve. The gray dots are the data generated by using the line plus or minus random scatter around the line, and the gray line at 0.1 milligrams per liter is a water quality criterion. The first segment of the transport curve is flat, indicating random variation in base flow concentrations. The second segment has a positive slope, indicating that total phosphorus is mobilized by increasing storm flow. SELDM is a stochastic model, not a deterministic model. If a model treats the upstream concentration as deterministic, the number of excursions depend on the chosen value. In this graph, the percentage of exceedances above the 0.1 milligram per liter threshold that occur downstream of a stormwater outfall are on the vertical axis. The total phosphorus concentrations shown on the horizontal axis represent a single value for the upstream concentration in each simulation. The highway values and storm flows vary randomly. We can see that the number of excursions increases from 0 to 100% as the upstream value approaches and exceeds the criterion. This is a totally unrealistic way to represent upstream water quality. In this training module, we learned that water quality is complex, and good data requires characterization in time, space, and with hydrologic variability. The training materials include information you need for further study. The highway runoff database indicates the importance of different constituents. SELDM can be used to simulate random, dependent, and transport curve water quality values.